Hello and welcome to our lesson on matrices. It's going to seem a little disjoint from the previous topics where we were talking about systems. And a matrix by itself, matrices by the way is the plural for the word matrix. A matrix on its own is not connected to systems, but using matrices is another option for solving systems. And we're going to get there, but today is just an introduction into matrices and some operations with those matrices. So when I say matrices or a matrix, what is it? A matrix is just a rectangular array, a rectangular arrangement of numbers, and then the numbers that are in that rectangular array or in that rectangular arrangement are called the elements of the matrix. And the rectangular array or arrangement is named by the number of rows that it contains, followed by the number of columns that it contains. So we're always naming by rows and columns, and that's one of the key things you'll want to imprint into the memory for a matrix. It's rows by columns. It's going to help as we move along into the multiplication, where rows are the horizontal. Think about someone rowing a boat on a lake. They're rowing horizontally along the lake. So rows are horizontal. That is the side to side, okay, dimension. And then columns are vertical. Columns are vertical, so that is the up and down dimension. So for example here, we're looking at two horizontal rows, and we're looking at 1, 2, 3 vertical columns, and so this would be a 2 by 3 matrix. And altogether, there are 6 numbers in that matrix, so those 6 numbers represent the 6 elements of that matrix. Okay? So we're going to look at some operations with these matrices, and then again, when we move along to the next topic, we'll see how this connects to systems. So scalar multiplication, addition, subtraction, this is pretty much order of operations. Scalar multiplication just means you're going to distribute a number into a matrix. So a number outside of a matrix is called a scalar. It'd be like having a number outside of a parenthesis. If you have a number outside of a matrix, you're just going to distribute that in or multiply that in. So it gets multiplied into the matrix. And if you're trying to add or subtract, you're only going to be able to add or subtract matrices that have the same dimensions. Because when you're adding or subtracting, you're going to be combining the elements that are in corresponding positions. So for instance, I could add A with B because they are both 2 by 2 matrices, and when I add them, I would be combining these elements and then the 1 and the 5, and then the 2 with the 4, and the 0 with the -1. So you would be adding or subtracting the elements that are in corresponding locations. Now, if you don't have the same size matrix, then some of your elements won't correspond, and that's why we cannot add or subtract. Okay? So they have to have the same dimensions, corresponding elements, in order to add or subtract. And if there is multiplication and addition or subtraction within a problem, we follow our order of operations where the multiplication would have to happen before any addition or subtraction. Okay, so some pretty basic operations here. So we've got matrix A, B, and C. The first one just says to find 3C. So if we're going to find 3C, that means we're going to multiply each of the elements in C, which are 1, -4, 8, 1/3, -2, and 0. We're going to multiply all of those by 3. So we end up with, after distributing the 3 to all 6 of these elements, we end up with 3 times 1 is going to be 3, 3 times 8 is 24, 3 times -2 is -6, 3 times -4 is -12, 3 times a third is going to be 1, and 3 times 0 is going to be 0. And that would be the result, as simple as that. Okay, 2 times A minus B, 2 times A, and I know some of this can be done in your head, so I'm just showing the work here just so I don't lose anybody, but if you could do multiple things at once in your head, you'd be totally fine doing that. So 2 times A is going to be 2 times, made this a little larger than necessary, 2 times 2, 0, 1, and 4, and then we're going to subtract B. So B is 3, -1, 5, and 2. So I'm going to go 2 steps here, but if you, again, you wanted to do this all in one, you could. And by that I mean 2 times 2 would be 4, minus the 3 could get you the 1. So if you could work that way, cool. If you need to show more work, also fine. So I'm going to show more work here. I'm going to do the multiplication first. So distributing in the 2, 2 times 2, 2 times 1, 2 times 0, 2 times 4 is going to leave me with 4, 2, 0, and 8. And now I want to subtract 3, negative 1, 5, and 2. And so that's going to leave me with, let's see, 4 minus the 3 is going to be 1. 4 minus 3 is going to leave me with a 1 here. And then I have 2 minus 5. And 2 minus 5 is going to be 3 in the next spot. And followed by 0 minus a negative 1. So be careful with the double negatives. Double negatives make a positive, so 0 minus a negative 1 becomes 0 plus 1, and 0 plus 1 is going to give me a 1 here. And then finally 8 minus the 2. 8 minus 2 is going to leave me with 6 here, and that would be our result. Okay, not so bad. Now b minus c is not going to be possible. B, I'm going to go back to right here. So b is a 2 rows, 2 columns is a 2 by 2 matrix. And then C is 2 rows, but then 1, 2, 3 columns. And C is a 2 by 3 matrix. Since those are not the same size, then the multiplication is not possible. So we could say that this is not possible. We could also say that it's undefined. Either one would be an acceptable response to a question like that. Okay, now last one, if you want to give it a shot. Again, I think this is pretty straightforward, but let's make sure we can add, subtract, multiply. Okay, so if you want to try it, pause the video and give it a shot. So b minus 3a. Okay, b is 3, negative 1, 5, and 2, and we want to subtract 3a, which is 2, 0, 1, and 4. So we want to make sure we do the multiplication first. We've got a couple of options. And what I mean is you can distribute just the 3 and then subtract the elements, or you could distribute the negative with the 3 and then add the elements, which is probably what I would do. I don't know. It doesn't matter. Either way, you're going to get the same answer. I'm trying to think what you would be more likely to do. Just make sure you're not doing the negative twice. So if you distribute a negative 3, don't keep the negative in between. If you distribute the negative 3, make sure you change to a positive. So maybe I'll distribute the 3. I'm going to leave the 3, the minus 1, the 5, and the 2. Leave the minus. If I distribute just the 3 to these guys, then I'm going to have left 6, 3, 0, and 12, and now I can subtract, and so my final answer is going to be 3 minus 6, and 3 minus 6 is going to be a negative 3, and then 5 minus 3, which is going to be 2, and then we're looking at negative 1 minus 0, which is going to still be a negative 1 here. And lastly, 2 minus 12, which is going to give me a negative 10 in that last spot. Okay, and there it is. Pretty basic addition, subtraction, multiplication. Okay, that is pretty straightforward. About as easy of a thing as we're going to take on in this particular module. The next operation, multiplication, not so easy. It's not that it's difficult, it's just we got to be really organized with our work, and it's really easy to misplace things, okay? So first off, 2 matrices can only be multiplied if the number of columns in the first matrix is the same as the number of rows in the second. So the number of columns in the first has to equal rows in the second, and if that's true, if those dimensions match, then the actual product, the answer, the result, is going to contain the number of rows from the first matrix and the number of columns from the second, which is already confusing. I'm going to try to help you organize just that piece. And now, multiplication is not commutative like addition. If I said to add matrix A with matrix B and then add matrix B with matrix A, you're going to end up with the same result. Normally with numbers, that's true for multiplication as well. So if you multiplied 4 times 5 or 5 times 4, you'd get 20 either time. Now, matrix multiplication is not, sorry, I meant 4 times 5, you're going to get 20 each time. Matrix multiplication is not commutative, so the order that you matter multiplies. So here, multiplying A times B or B then A is going to make a difference in your answer. So matrix multiplication is not commutative. Commutative property says we can change the order in which we add or subtract, or sorry, add or multiply and still get the same answer. It's true for integers or real numbers in general, but not true for matrix multiplication. So that means the order that you multiply matrices matters. Okay? So how does this work? Okay, what we said, or what I said up here, is the rule is true. The number of columns in the first has to match the number of rows in the second, and then the answer is going to contain the number of rows from the first and columns from the second. Well, that's a lot. So what I would like, or what I do to try to first wrap my brain around, is the multiplication possible and what is my answer going to look like? The first thing I do is I label the matrices by their size. So in number 4, for example, the first matrix here is containing 1 row and 3 columns. 1 row, 1, 2, 3 columns. So that is a 1 by 3 matrix. And we're trying to multiply by a 1, 2, 3 row matrix and 1 column matrix. So 3 rows and 1 column. So in order for the multiplication to be possible, the number of columns in the first has to equal the number of rows in the second. So those two numbers have to be equal. If they are, then we can multiply. And then the product is going to contain the number of rows from the first and the number of columns from the second. So if the two in the middle there are equal, then the answer is going to be the size of the rows by columns, so the other two dimensions. So the answer is going to be a 1 by 1 matrix. Okay? So this is just not even any work here. This is just to decide, can we multiply and what will the answer look like, which in my opinion is halfway through the struggle, okay? So these can be multiplied because the number of columns in the first is equal to the number of rows in the second, and the answer is going to contain the number of rows from the first and columns from the second, so it's going to be a 1 by 1 matrix. So this is going to be a 1 by 1, gosh, 2 times. 1 by 1 matrix. So 1 by 1 matrix means there's just going to be one element in here. Okay, one element in a 1 by 1 matrix. Okay, in a 1 by 1 matrix, we'll have one element. Okay, so how do we get the one element? Okay, what we're going to do to get our one element is multiply. So this is one spot, right? It'll be a little, or just go with me for a second here. This will get easier as we go through a few more problems. But in this one spot, this is like row 1, column 1, right? We're going to take our row from the first and multiply it by the corresponding entries in the column from the second. So we're multiplying the 1 and the 4, the 2 and the 5, and the 3 and the 6. And 1 times 4, 2 times 5, 3 times 6, those results will be added together. And I didn't write that big enough, so let me do this again. So 1 gets multiplied by 4, 2 gets multiplied by 5, 3 gets multiplied by 6, and those products get added together to find that one entry. So 4 plus 10 plus 18 is going to be 10, 20, 32. So this result is 32. That is the resulting product of those two matrices. Okay? Just crazy, I know. I know. let me just use some different colors here. This is all too much. So 1 got multiplied by 4. That's when I got this. And 2 we multiplied by 5. That's where we got this. And 3 got multiplied by 6, and that's where we got this. Okay, so we find the product of the row and the column, and then we add those products together to get our entry. Okay? Whew. All right, let's try another one. First, we need to identify whether or not this is going to be possible, and if it is, what our answer is going to look like. So this is a 2 by 2 matrix, a 2 by 2, and we're multiplying by another 2 rows by 2 column matrix, so another 2 by 2. Okay? So obviously this is going to work. What we need is for the number of rows or columns in the first to equal rows in the second, and that's true. Since those are equal, we can multiply, and our answer will contain the number of rows from the first and columns from the second. So our answer is going to be a 2 by 2. The answer is going to be a 2 by 2. Okay? So when I go to set this up, I want to put space in here, a lot of space in here, because we're going to be doing lots of multiplying and then adding. I want to build this 2 by 2 matrix. So in a 2 by 2 matrix, we're looking at 4 elements. Okay? 4 elements. So 1, 2, 3, 4 spots we have to try to fill in there. Now, think about the location of each of those spots. And remember, rows by columns, that's how we identify a matrix. So this very first spot here is in row 1 and column 1. And this second, the spot underneath it, this is row 2 of column 1 in that answer. And then if I go to the right of the first one, this is still row 1, but it's in column 2 of the answer. And then this last spot here is in row 2 and column 2 of the answer. Now it's important to be able to identify those because the spot in the answer is going to tell you what to multiply to produce the result in that spot. So for example, if we are looking at obtaining row 1, column 1 of the answer, then I have to use row 1 and column 1 to get that. So row 1 of the first matrix and column 1 of the second matrix is going to produce that result. So I'm multiplying the 2 times the 1 and the 6 times the 7. So it's 2 times 1 plus 6 times 7. Okay? Try not to, make a huge mess here, but I do want to make sure you follow what I'm doing here. So row 1, column 1. Okay? Now, in the next spot, I'm looking at it's going to be too much highlighting, so I'm going to have to be careful here. So in this next spot is row 1, column 2. So to obtain row 1, column 2 in my answer, I'm going to multiply row 1 by column 2. So row 1 of the first matrix, column 2 of the second. So to do this, I will be multiplying the 2 with the 5 and the 6 with the 9. So 2 times 5 plus 6 times 9. Oops, that's a negative 5. Okay? So we're moving right along. Next, I'm going to look at running out of colors. It's fine. Row 2, column 1. So if I want to produce row 2, column 1 of my answer, then I want to use row 2 and column 1 in my matrices. So multiplying row 2 and column 1 is going to be 3 times 1 and negative 4 times 7. So 3 times 1 and a negative 4 times 7. And then lastly, I used all these colors. Let me, what's a good one here? Oh, we haven't really used a reddish. Okay, so if we want to find row 2, column 2, then I want to use row 2 and column 2. So row 2 and column 2, again, is going to be 3 times negative 5 3 times negative 5, and 4 times 9, negative 4 times 9. And there it is. Okay, that was the hard part. Now the easy part is just multiplying and adding to figure out this simplified matrix. So here, 2 times 1 is 2, and 6 times 7 is 42, so 2 plus 42 is going to give me 44 here. And then I'm going to go to row 1, column 2, where I have a negative 10 and a positive 54. So that's going to leave me 44 again. What are the odds of that? And then here I have 3 minus 28, which is going to be a negative 25. And then lastly, I'm looking at a negative 15 and a negative 36. So that's negative 51 altogether. And there you have it, folks. Okay, that is the product of those two matrices. Now, you might be wondering at this point, is this something that Desmos could do? Unfortunately, not. I do think Desmos has a beta version of a matrix calculator. So if you Google Desmos matrix calculator, it might pop up. It was under construction the last time I tried to access it, so you can try, but you still have to enter the matrices and ask it to do the multiplication, which gets a little tricky. If you have a graphing calculator, your graphing calculators will typically do this for you, but again, you have to know how to type the matrices in, how to edit them, and ask it to do the product. So if you want to play with your calculator, or Google how to do it with the calculator if you have one, or again, Google Desmos matrix calculator, you might be able to play with those things. But since not everyone's going to have the same thing, I can't exactly show you how to do this with a calculator. So I'm going to continue to show you how to do these by hand, which is a good skill, I suppose, good practice for you. Let's look at this next guy. So we want to identify if this is going to be possible. This first matrix is a 2 by 2 matrix. And then this next one is 1, 2, 3 rows by 2 columns. So this multiplication, not possible. What a bummer. You're bummed, right? This is not possible because 2 does not equal 3. So since these are not equal, this is not possible. Again, you could say not possible. You could say the product is undefined. Either one of those would be an acceptable response. Okay? So that'd be best case scenario. We wouldn't have to worry about messing with that. All right, how about this one? Here we're looking at a 1, 2, 3 by 2 matrix, and then we're trying to multiply by a 1, 2, and 2, a 2 by 2 matrix. So this is definitely going to be possible because the number of columns here equals the number of rows here. So since these two are equal, we can multiply, and our answer is going to be the number of rows here by columns here. So our answer is going to be a 3 by 2 matrix. That's our answer. So we're going to be, again, trying to find a 3 by 2 matrix, which is going to have 6 elements. Okay, so a 3 by 2 with 6 elements. That's 3 rows by 2 columns. Okay, 1, 2, 3 rows by, scooch that over, 1, 3 rows by 2 columns. So that's what our answer is going to look like. Okay, now let's identify where each of these elements is in this result in this answer matrix. So this would be in row 1, column 1 of the answer. This is row 2, column 1. This is row 3, column 1. This would be row 1, column 2. This is row 2, column 2. And this is row 3, column 2. So now I know exactly what to use to try to get each of these entries. So to get, let's go with yellow here. Row 1, column 1, I'm going to use row 1, column 1. So row 1, column 1 is going to require multiplying 3 and 2 and 7 and 3. So it's 3 times 2 plus 7 times 3. And now I'm going to go with row 1, column 2. So row 1, column 2. That's 3 times 6 and 7 times negative 4. 3 times 6 and 7 times negative 4. Okay, and now I'm going to look at, let's change colors. Row 2, column 1. So row 2, column 1 is going to be multiplying 4 and 2 and 1 and 3. 4 times 2 plus 1 times 3. And now I'm going to go with just dots everywhere. Row 2, column 2. So row 2, column 2. That's 4 times 6 and 1 times negative 4. 4 times 6 and 1 times negative 4. And we're getting there. Last, what did I not use? Blue. Let's go row 3, column 1. So row 3, column 1. 6 times 2, negative 2 times 3. 6 times 2 plus negative 2 times 3. And finally, we are looking at row 3, column 2. Row 3, column 2 is going to be 6 times 6 and negative 2 times negative 4. Oops. Negative 2 times negative 4. Okay. Whew. So the hard work is done. Now the easy work, where we just do some multiplication and addition. And it would be a real bummer for you to get all of that right and mess up with the multiplication and addition. So by all means, use your calculator if you're not so comfortable doing the multiplication and addition. Or not that you're not comfortable, but you just don't want to make a silly mistake. Okay? So I'm going to go ahead and use my calculator on these last few products and sums, just so I don't do anything dumb. So 3 and 2 and 7 and 3 gives me 27. And then 4 and 2, 4 times 2 plus 1 times 3. It seems a little silly now that I'm typing this into the calculator because it's mental math, but whatever. No shame, no shame. Alright, last one I get 6. Let's go to the next column. So 3 times 6 and 7 times negative 4 gives me a negative 10. 4 times 6 and 1 times negative 4 is 20. And then lastly, 6 times 6 minus 2 times negative 4 is going to be 44. And that is our answer, crazy as it is. Okay? So, I know this is a very detailed process. Again, the more organized you can be, the easier it's going to be for you. So I think this would be a good opportunity for you to try this, wrap your brain around the whole thing. So if you're feeling comfortable enough, pause the video and give it a shot. Otherwise, let's work through this guy together. This one's obviously going to be possible. We've got a 2 by 2 matrix here, a 2 by 2 matrix here. We said one of these, right? Yeah, we did one of these earlier. So because the number of columns here and rows here is equal, because these two numbers are equal, then we can multiply, and our answer is going to contain the number of rows from the first and columns from the second. So our answer is going to be a 2 by 2 matrix. So we're going to have a 2 by 2 matrix, which means it's going to contain 4 elements. Alright, so 4 elements in these 2 rows and 2 columns. So 1, 2, 3, 4. And this would be row 1, column 1 of the answer. This would be row 2, column 1. This is row 1, column 2, and this is row 2, column 2. So I'm going to use row 1, column 1 to get that result. Row 1, column 1. That's going to give me 1 times 2 minus 5 times 3. And then I want row 1, column 2. So row 1, column 2 is going to be 1 times 6 and negative 5 times negative 4. And then, oops, let's see, orange, row 2, column 1. Row 2, column 1 is row 2, column 1 here. So 7 times 2 and 9 times 3. And finally, row 2, column 2, row 2, column 2. This is going to be 7 times 6 and 9 times negative 4. And there it is. That was the hard part. Now the easy part. Okay, let's do some math here. So this is going to be 2 minus 15, which leaves me negative 13. This is 14 and 27, which is 30, 41. And then here, 6 plus 20, so 26. And then lastly, this one is 42 minus 36, which is going to be 6 altogether. And we did it. Okay, got through all of those. Matrix multiplication. Probably one of the more challenging things we've seen in a while, just organizationally. It's not that adding and subtracting and multiplying is hard, but keeping track of what you're doing is definitely the tough part here. So hopefully I've given you some organizational tools that are enough to help you along. But if you need some extra guidance, assistance, or just help on any particular problem on the practice, feel free to reach out. All right, guys, take care.